Finding trig ratios from a given trig ratio, such as if cosine theta is rad 13 over 7 and sine theta is less than 0, find all remaining trig functions. Well, there's a couple things we need to know to be able to do a problem like this. First of all, you need to know that ASTC, all students take calculus, is our way of remembering where these things are what signs. And here they're clearly telling you sine less than 0. They're telling you that sine is negative. And so sine is negative in quadrants 3 and 4, because the A means all positive and the S means sine positive. We're looking for sine negative. See, all of these functions are positive in 2 quadrants and they're negative in 2 quadrants. Sine is negative in quadrant 3 and 4. Cosine, they're telling you it's rad 13 over 7, but they're also telling you that it's a positive rad 13 over 7. So not only is it giving us a specific ratio, but it's also telling us the sign, because the sign of the fraction, the sign of the ratio, is positive. And cosine is positive where they're all positive, and that C stands for cosine positive. So we know we're in quadrant 4. And so we need to draw ourselves a picture of a triangle in quadrant 4. And remember, the way to draw a triangle is always connecting the origin to a point and then to the x-axis. And theta at the origin and the right angle is the vertical and horizontal line. So we know that cosine theta is rad 13 over 7, and cosine is adjacent over hypotenuse. So that's giving us two sides. Adjacent is always the x-axis, and the hypotenuse is always the slant line from the point to the origin. What we're missing is the opposite side. But a little Pythagorean theorem can help us determine that. 7 squared minus rad 13 squared, that's going to be 49 for 7 squared minus rad 13 squared. That's 49 minus 13 is 36. We're doing square root of 36 is 6. But what we have to be careful here is that think about where we are. It's not going to just be 6, it's going to be negative 6, because we're on a vertical line below the x-axis, just like the vertical line below the x-axis is the negative y values. And so you have to know to label that a negative 6. And just a recap of that real quick, if we draw our quadrants with our bow tie, how we draw our triangles, remember that the x-axis is simple. It's positive over here and it's negative over here. And when it comes to the y-axis, it's positive here and here because the y-axis is positive there. And it's going to be negative down here because the y-axis is negative down there. And when it comes to the hypotenuse is positive no matter what. But we have to remember that sign. So a big part of that is this is not going to be 6, it's going to be negative 6. Pythagorean theorem is always going to tell you positive, just because that's how we do it. But you got to know, based on its location, that if we were up here, it'd be 6, but because we're not, it's a negative 6. Here it'd be positive 6, here would be negative 6, and so on. So that's a common mistake, is people put the wrong sign. But now that we have that, we can find all the functions. Sine theta is negative 6 over rad 13, negative 6 over 7, excuse me. Negative 6 over 7. Its reciprocal, cosecant theta, is negative 7 over 6. Cosine we have, but we could also see it's rad 13 over 7. Its reciprocal secant is 7 over rad 13, but I'm going to write it as 7 rad 13 over 13, so it's rationalized. And tangent would be opposite over adjacent. Negative 6 over rad 13 is going to be negative 6 rad 13 over 13, so it's rationalized. And cotangent theta is negative rad 13 over 6. And actually can find angle theta from any one of these 6. But to truly understand that, we have to have a good grasp of reference angles, and we haven't quite got to that yet. So we'll get to that in a couple of lessons.